Good morning, everyone. And we have a very, very special guest today, Dr. Debbie Steinberg. Welcome, Deb.
Thank you. Hi,
So
everybody.
you've had quite the drama this morning, so hopefully this will be a little bit more relaxing. Full disclosure, Deb, you are my PhD advisor.
That's right.
We're all very lucky in life that we get to meet and interact with some very special people. And for me, you are this person. Yes.
Thanks, Rob.
So I'm thrilled to introduce you, of course, but I'm really thrilled to have you here today and have all the young scientists from not only Wilmington and around the place getting the opportunity to interact with you and hear about what you do for research and just sort of soaking in all the advice that you can give as they embark on what I'm sure is going to be a successful career in whatever they choose to do. Yes. So we're going to talk about the global ocean. And we're going to talk about the largest migration on Earth.
We are indeed. Yes.
Good. So
Great.
I'll pass it over to you. And
Okay.
So can you share your screen?
Yeah, let me do that.
And while you're doing that, I'll just remind everyone, if you have a question, you can put it into the chat, and please ask lots of questions. And I can control microphones and things like that.
All right. So can you see my screen now? So it should say animal migrations.
Yes.
Okay. Great. Hi, Dad. Well, first I want to welcome everybody to this little short talk about animal migrations. And before I start, I just want to mention a couple of things. One is that I'm sorry about you. I look a little different than I normally do. You may notice I have a big. I had an interesting time these last few days. I fell on my living room floor and right flat on my face. So normally I don't have a big black eye, but just to let you know, you should see the other guy. And we did have some drama in my house this morning. My son's bike got stolen, and so we've been dealing with that. So anyway, lots of interesting things happening over here on my end. But what's most pertinent to you guys is I am an oceanographer, and I spend a lot of my time studying the organisms of the ocean, and I go out on research cruises, and I've been all around the world going to sea and doing my research. I'm also a professor, so I teach marine science, and so I'm very happy to share with you a little bit of information about the largest migration on the planet. And I want to start by just asking you, and maybe you can you raise your hands or however you've been doing it. Have any of you ever gone away on a trip kind of far away from home? A long car trip, or maybe you've been on an airplane.
That's me.
All right, good. So I hear at least one of you have, and I'm sure more of you have been most of them been away from home at some point. And so I want you to know that lots of animals take trips too. And when they do, we say they migrate. And but not all animal movement we call migration. Move a pretty long distance, and often this migration happens at a certain time. And so one thing that most people are familiar with are birds flying south. for the winter. That's a really good example of an animal migration. And some of the migrations that you might have heard about, some of the famous migrations are the migration of the caribou in Alaska. And so these are, it's a herd of caribou. They migrate every summer, and they can go 3,000 miles in their migration, and they move in this sort of big loop here. This pink trace here over Alaska is the migration of the caribou, and in the summer they go up north to an area near the Arctic Ocean where they feed, and they have their calves, and that is 1,000 miles on that loop, and they do it every year, and the herd just travels around and they feed, they have their calves, and then they go south again before the winter comes, where it's a little bit warmer. So that's a land migration. There's also like migrations in the air, and the most famous one maybe and the longest one is by the Arctic tern, and that's a picture of the Arctic tern there. And in their migration, they go an amazing 22,000 miles from the north to the South Pole. And so they spend their summers in the summer in the northern hemisphere, feeding near Iceland and Greenland, and then they travel all the way south to Antarctica in the very, very food-rich oceans surrounding Antarctica. They feed down there, and then they go back again. And so they do this annual migration, an amazing distance.
Yeah, so there's here in North Carolina, southeastern North Carolina, we have Bald Head Island, very similar to the Outer Banks, right? And so it's kind of like a hot spot for a lot of these birds that are migrating. You know, they're coming from Mexico, or they've traveled all the way over the Gulf of Mexico. It's amazing to see this happening every spring. And
yeah, and some of you students may have seen birds that you don't normally see in your backyard every day, and then those are some of these migrating birds, and they do love to stop on the east coast of the US, especially in places like North Carolina, near the coast there, where there's food for them. Also migrations in the sea. And one of the most well-known ones are the migration of the humpback whales. And probably most of you have heard of humpback whales. This is a mama whale here with her calf. And humpback whales migrate almost 10,000 miles every year. They spend the summers in feeding grounds up north in the North Pacific, near Alaska and Russia, and there's lots of plankton up there that they feed on. They filter out very small drifting animals in the ocean, which we're going to talk about more in a moment, called zooplankton, and things like krill, and they feed on these plankton and in the summertime. And then before it gets too cold up there, they all head back down to Hawaii, which I think is spend their summer in Hawaii, where it's nice and warm, and that's where they have their calves, their babies, and they have their babies in the nice warm water, and the babies grow up there for a while, and then they do the annual migration again with their babies once the babies are big enough to be able to swim all the way back up to Alaska. And so that's the migration of the humpback whale. So we have migrations on land and in the air and in the ocean. So what I want to tell you about is an ocean migration that not many people know about. That is actually, in terms of the number of animals that migrate, it's the biggest migration on our entire planet. And it's done by these animals here. They're called zooplankton. And these little animals are very important in the ocean food web. And this is a picture of a very simple ocean food web here. We have the little plant drifters, the phytoplankton. And these are the plants. They're just like the plants on land, that they undergo photosynthesis. They take the energy from the sun and they make sugars, and they produce food for zooplankton. And the zooplankton are almost like the little insects of the sea. These are small little animals, and they eat these phytoplankton. And in turn, the zooplankton get fed on by things like fish or jellyfish, things that, especially the fish, which many of you may like to eat. And in fact, what they're eating are the zooplankton. And so some of this gets consumed by bacteria too. And so these are, all these different animals are connected in ocean food webs. Now, the zooplankton, many of them just hang out in the surface waters all the time, feeding on the phytoplankton that live in the sunlit zone of the ocean. And here's some other pictures of zooplankton. This is a copepod here, about the size of a rice grain, and we have a little beach, this is called an amphipod. It's kind of like a little beach hopper that you might see at the ocean shore. And on the right there, we've got some jelly plankton. And those are ones that you might be a little less familiar with. And these are, this is called a salp. And we have another big one here called, it's kind of like a colonial jellyfish. And these are all, these are all found in the ocean. And many of them undergo this migration. We call the migration diel vertical migration. And it's called diel because it happens over the course of a day and a night. And it's vertical because these zooplankton are going up and down in the ocean. So this is how it works. In the deep, dark waters of the ocean, there are zooplankton that spend their days down there. And at nighttime, these zooplankton swim up into the surface waters where all the plants are growing to feed. And they hang out there in the surface waters most of the night, happily eating. Just before the sun comes back up, they head back down to depth again. So they spend their nights feeding in the surface waters, kind of like you get the munchies at night and you go into the kitchen and you go and have some ice cream, even though you've already had dinner. You know, you go there and have something to eat, and then you go back into your room again before the sun comes up and realize that, before your parents know what you've been doing. All right, so this is called diel vertical migration. So let's put this into perspective about how far these animals are actually traveling. So these little animals, and the example I'm using are copepods. So this is a little 2 centimeter, about an inch long copepod. And every night, this little, about 1/3 of a mile to feed up in the surface waters. So if you divide that 500 meters by the 2 centimeters that this animal is, that's 25,000 body lengths. So it's traveling 25,000 times its own body length up into the surface waters every single night to feed. Now, let's compare that to maybe somebody that most of us are familiar with. So here's Spider-Man. I believe he's a Marvel character that maybe you're familiar with. So let's say Spider-Man's about 6 feet tall, 1.8 meters tall. And so if you consider how many body lengths Spider-Man would have to travel to go that, you know, that many body lengths, that's 45,000 meters. That's 25 miles or 28 miles that Spider-Man would have. So for those of you who are living in North Carolina, where Dr. Rob is, that would be like getting in your car and going from Wilmington all the way to Cure Beach, to the beach out there, and you'd have to walk that whole distance every single night to go there. So that's a pretty long way for such a little animal to travel. So I just want to give you a sense of how far that really is for such a little teeny animal.
And that's a direct route as well. And there's everyone like around here knows that the roads are busy and all that type of stuff here as well. So.
Exactly. That's right. Especially, in the summer.
How fast is the migration?
Yeah, so what's really amazing is it only takes them a few hours to get up. Pretty good clip to get up there. So they're arriving up at the surface waters within maybe just a few hours. And they usually, the downward migration might be a little bit quicker because part of that they can just sort of sink. So how do we know about this migration? Well, it turns out that we first found out about it in the days of submarine warfare back in the World War One. Well, I guess it was a little before World War II, and in the 1940s, so just before World War II, they were doing submarine warfare, and they noticed that as they were looking for other submarines, they would use sound to try and detect other submarines. And so the submarines and the ships would, the ships on the surface water would emit sound to try to find these submarines that were trying to torpedo them. And the submarines, if they were down there, would reflect the sound. And that's how they found these submarines. And in the course of doing this, they saw that there would be these shoals or these sound scattering layers that would come up every night. And they knew that they were so vast, they were so large, they knew that it wasn't a little submarine because it was happening across the ocean as far as they could see, as far as they could tell. And then they'd see the layer go back down. What is this big animal migration? And they called it the deep scattering layer because it was scattering the sound. And so the deep scattering layer, layers of sound scattering in the ocean due to the reflection of sound by these migrating organisms. And it turns out that it's these little zooplankton, like the copepods I told you about. It's they have little lipid droplets or fat droplets in their bodies that reflect the sound. Or this is a deep sea fish called a lanternfish that has a swim bladder that's filled with air that reflect the sound. And even some jellyfish have, this one has carbon monoxide, which is a type of gas in its swimming bell that reflects the sound. And so what the ships would see was something that looked like this. So if you look on the right side of your screen here, off of California. And during the day, this green stuff here, this is an echogram from, this is a sound scattering layer. And what happens is that as it starts to get dark, you see that scattering layer starts to move up to the surface. And then at night, it's spread out in the surface waters. So you're looking basically at a cutaway of the ocean here. And then as before the layer starts to move down as the sun comes up. And so in the middle of the day, down here at the bottom, you can see the layer is deep again. So that's this diel vertical migration. Now, this is another one of those little scattergrams here. This is what you're looking at again is a cutaway of the ocean. And this whole thing here is this layer of millions of these migrating animals. And this particular scattering layer is formed by this fish right here, which is a lanternfish. And this is what the actual scattering layer looks like. So I'm going to play this little video here. So those are thousands of these little myctophids that are migrating. So it's not only zooplankton that do this migration, but these little, lanternfish that are migrating up as well to go feed in surface waters.
So Deb, these fish are bioluminescent?
Yes, and I hear that you all recently learned about bioluminescence.
That's right. Yes, we had Steve Haddock and George Matsumoto on last week talking about bioluminescence. It was very cool.
Did they show you all some pictures of lanternfish?
Yes, they did. Yeah, and even like their brand new sort of ROV that does the in situ like bioluminescent measurements and stuff. It was
perfect.
Yes. It must be nice to have the money to spend on that technology to be able to do that pretty cool stuff.
Yeah, exactly. And in fact, the ROV that they showed you all in their presentation was the same or very similar to the ROV that actually took this footage of these lanternfish here. So yeah.
Right.
That's neat.
And then I read recently about some work where they retrieved a lot of these myctophid fish and then dissected out their guts. And maybe I could ask my young scientists, what do you think a common food item outside of plankton was inside the gut of these fish? Angie says ooh, but do you want to take a guess at what was inside the gut? Anyone? It was plastic. They found a lot of microplastics. Yeah. Yeah.
Yes, that is that's a big problem in the ocean these days. Absolutely. Yes. Yeah, we're finding things that shouldn't be there in the guts of these animals. Yep.
Ben actually has a question regarding this picture here.
Yeah. I'm not on the chat, but I can put myself on the chat, or I don't know how you're doing questions, Rob. Or maybe you can just tell me what.
I can control it here, so I'm going to unmute the microphone.
One of your questions.
All right, go ahead, Ben. Ben or Cora?
Is that the same kind of technology used in fish finders?
Yes, that is the same technology used in fish finders. Echo sounders. Yep, it's the same thing.
When you say the zooplankton are eating plants at the surface, do you mean other plankton?
I do, yeah. So those are plant plankton. So the word plankton means to drift or to wander in Greek. And so phytoplankton, phyto, that root means plant in Latin or Greek, okay? So that's phytoplankton or plant drifters. And zooplankton, zoo means animal. So zooplankton means an animal drifter. And the animal, those zooplankton eat the phytoplankton. So they're different kinds of plankton. And these fish, by the way, are well, when they're not eating plastic, what they're supposed to be eating is zooplankton. So these myctophids, these lanternfish feed on the zooplankton. So that's the food web. Good questions.
Yes, very good question. Any other questions? I know.
So I wanted to, since I do some of my own research on these vertical migrators, and so I wanted to show you some footage from one of my research cruises. This one was in the North Pacific Ocean from just a couple years ago. And vertical migration, we were looking to see which animals were migrating and how far they migrated. And so you can use those submersible robots with cameras to do some of this work, but we also sometimes have to collect them so we can count them properly. And so one of the tools we use is this net here, which both Dr. Robb and Mrs. Smith have used in their research too. It's called a mock nest. And it is, which has it's an acronym that has this, stands for this big long phrase here: multiple opening closing net and environmental sensing system. And what the mock nest does is it has 10 different nets on it. And so what you see here, there's a picture of the mock nest, and we're deploying it from the ship. And so first I'm going to show, a little windy out there. And so
this is off the coast of Japan, right? Yep.
Yeah, this one is actually about a 4-day trip on a boat straight out from Seattle. And so we are in the middle of the ocean there, and they're deploying the net on a wire, and we're going to send it down to 1,000 meters in the ocean to catch these migrators. And we do the net tows both during the day and during the night. And so let me show you it now over here. This shows you it going into the water. And you can see all those different buckets at the end of those 10 nets, and that's called the cod end of the net. So what happens is we send this all the way down to the bottom, and you can see this first one here is open. And what we do when we get to the bottom is we close this net, and by closing that net, it opens the next one. And then we start to fish, and we start to tow the net up, maybe a couple hundred meters, and then there's a bar that closes that net, which opens the next one, and then we tow it up another 100 meters, we close that net. So we just keep opening and closing these nets as we're bringing the net up to the surface. And so the very last net samples the surface water. So that way we get samples at different depths of the ocean, and we get to see what animals are living at the different depths, and we see how does that change between the nighttime and the daytime. And that way we can tell which animals are migrating and from what depths are they migrating.
And
now I'll show you. Oops.
I was going to say, Oliver and Reese were asking, so that the nets that are opening and closing are controlled by a computer, right? So it's attached to a wire on the deck of the ship.
That's right. And that wire has, electricity flowing through it. So it's opening and closing the nets. And it's also feeding us information up on the ship. So we know exactly how deep the net is. We even know things, it's telling us also what the temperature of the water is down there and how much oxygen is dissolved in the water. It's giving us all sorts of information. And then, so we have lots of information about the habitat that these organisms are living in, not just, who's down there, but what's the water like? What's the water like down there? I'm going to show you some of the migrators that we. This is what you're going to see here. This is a little copepod. So again, these are those rice grain size little zooplankton. They're the most numerous animals multicellular animals on our planet. And And they live everywhere in the oceans. You've been swimming around copepods without even knowing it when you go to the beach. And this is a big copepod that lives in the North Pacific Ocean. And so we caught some of these copepods in our net. And so this is a jar here of, whoops, sorry, let me go back here. This is a jar of these little copepods. So I'm holding the jar so you can get a sense of sort of how big the jar is. So those copepods are, a couple inches long. You can see they look kind of like insects, right? They're swimming around in the jar, and they've got antennae, just like insects have antennae. And there's hundreds of them in there.
This is Neocalinus?
This is Neocalinus, one of the biggest copepods we have in the ocean.
So at YSA, we've been doing a lot of plankton identification in the Cape Fear River and also the lake. There's lots of freshwater copepods, but these are the ones here in the river are much smaller than these.
Yeah, these are big ones. Yeah, that's right. And copepods live in freshwater. By the way, this diel vertical migration not only happens across the world's oceans, but it also happens in lakes, in streams. So it happens in freshwater as well. So those are some of the migrating copepods. Now, I hope you all been wondering, why travel all that way? Why not just stay in the surface waters all the time? Why not stay in your kitchen next to the refrigerator where you could eat ice cream and other things anytime you want? And also, how do they know to do it? So let's talk about that for a minute. So first of all, how do they do it? Well, you might have guessed that light plays a role because it's happening on this light cycle, our natural, light cycle of the day. So light is the cue for the migration, okay? So they know, the animals sense when there's a change in the light, and light can penetrate actually pretty deep in the ocean, even though most of the light, that sunlight in the ocean disappears within the top 100 meters or even shallower. Once you get down deeper, there's not very, we call it in essence, you learned about the mesopelagic or the twilight zone. And so that's the area of the ocean where there's only very dim light, and very few animals can actually sense the light down there. And even deeper than that, there's no light. And that's where bioluminescence is the only light. But these animals that are living in this twilight zone where there's just a little bit of light, they can detect very slight changes in the light from above. And so light is the cue. They know when that sun's starting to go down, that's when they start to do their upward migration. Now, they also, part of it is what we call circadian rhythm. So it's the natural daily rhythm that animals have. And you have a circadian rhythm. You sort of naturally want to go to bed, when it's dark, and you want to get up when it's light. Now, I know since we've all been stuck at home with this virus, lots of our circadian sleep until 1 in the afternoon. But normally the natural rhythm would to be up during the day. And so these animals in the ocean also have an internal rhythm that also controls the migration. So that's how they do it. Now, why do they do it? Well, the major reason is this: they are trying to avoid getting eaten. So the idea is they feed under the cover of darkness in surface waters where all the plants are, right? Because the plants aren't down deep. There's not enough light for the plants to grow down deep. So the only place where the plants are is up in the surface waters. So they like to, if they want to eat the plants, but they don't want their predators to see them, they feed under the cover of darkness at night, and they can feed in peace and not have to worry about being And then before the sun comes back up, when they would be visible to their predators again, they head back down to the deep, dark waters where they hide. So what they're doing is they're hiding in the deep, dark waters during the day, and then the sun goes down, and then they rise and swim to the surface at night to eat under the cover of darkness. And then just before the sun comes back up, they head back down again to rest. And so that's why they do it. So this, again, is a migration. It's the largest migration that happens on our planet. More animals do this nightly than there are caribou who are migrating, or Arctic terns, or wildebeest in Africa, or butterflies traveling from the Arctic down to Mexico. This is the greatest migration on our planet. So I'd be happy to take any further questions that you have, and thanks for listening.
Awesome. That was great, Deb. I know that Angie had a question early on that's related to what you were just talking about, but it was bird triggers and migration.
Here, I'll stop sharing my screen. Oh, there we go.
There we go. Yeah,
perfect. Thank you.
So Angie, if you want to unmute your microphone.
Let me find where it was. I asked, how do animals know where they go before winter comes?
Yeah, so the animal migrations they have for some of these organisms, we don't even know how they know, but some of them, it is in their genetic code. They know. Some animals are using the magnetic field of the planet. They can sense where they are and can navigate that way using other chemical and light cues. So there's a whole bunch of different signals that organisms are using.
I remember the solar eclipse. When was that? Last year, year before, 3 years, like the middle of the day, and bats were coming out in the middle of the day because it was dark. Yeah,
that's right. That's right. And in fact, the bats came out. Normally they're nocturnal, so they came out during the eclipse. And in fact, we know that for the zooplankton and fish in the ocean, when there's a solar eclipse, they'll start migrating in the middle of the day, because they think it's nighttime.
That's pretty wild. Bethany has a question.
All right, Deb, so I need your help to solve this debate. I think it started a couple weeks ago when Rob had Josh Stone on. And we were trying to figure out what our favorite zooplankton was. So do you have a favorite one?
Oh, it's such a hard one, Bethany. I will say, I think my favorite one is it's an open ocean snail called a heteropod. And this particular one looks like an elephant. So in the ocean.
At YSA, we have one in a jar. Everyone.
You do?
Yes.
It's got a snout. It looks like a snout, and it is just the cutest darn thing. And I guess if I had to pick one, I would. There's lots of really, really cool zooplankton, as you know, Bethany. And so would Rob know.
I want to hear Bethany's favorite.
Oh, that's a toss-up. Tomopterus is on the top of the list.
Mm-hmm.
And I really love pteropods.
Yeah, there's some great one. And I'll have to tell all you students, and I think that Rob and Bethany feel the same way, and I'm sure that Josh Stone does as well, is we've all studied zooplankton. And, for me, I've been doing it more than 30 years now, and I still love looking at a zooplankton toe never get tired of it because there's always something I haven't seen before. There's always something different. So, yeah.
That's so true. Like we can do it. I remember the first time we got a leech in a toe.
Yeah.
at the lake, which is not in pristine condition. But,
right. Yeah.
It's fascinating. And the time that we tried to figure out what this insect larva was, it turned out to be some sort of butterfly.
Yeah.
It's just fascinating.
Yeah. There's just always something new. And I remember that, the first time I ever looked was in 6th grade. I remember very clearly. We went down to the little stream in my elementary school, and we got just jars and just dipped them into the stream, and we brought them up into the classroom. And that's the first time I ever saw zooplankton. I remember it very clearly.
So we have lots of young scientists that are, looking for career paths moving forward. Do you have any advice? Like, let's say you're in upper elementary school now. What should you be thinking about in terms of like classes that you want to take, or just general advice for someone that wants to aspire to be some sort of scientist or engineer?
Well, my advice would be to get experience with people who are doing science, and to look for opportunities to help out on a boat, if you're interested in marine science or aquatic science, or to work in somebody's laboratory, to take advantage of summer camps maybe, or classes that teach about science, like you're doing now in this online class. And to take certainly science, it's school and high school, and math, but you should know that a big part of science is also writing. So not many people realize that how much of science is writing about what you found. And so that's also really important. So being a scientist isn't just crunching numbers and on the computer and figuring out how many of this and how many of that. Some of it, and a big part of it actually, is also writing about what you found and sharing it with other scientists. And that's the way that science moves forward. So I would also say that, really don't, really realize that your English classes and learning how to write well is important too.
Yes, Bethany just wrote what I was about to say. That is today's soundbite, and I'm going to put that on a loop for like an hour and a half and send it to all my students. And what's been like the biggest challenge so far in your illustrious career, Deb?
The biggest challenge.
Maybe pick it like an early career. What was like a big challenge for you? There are a lot of challenges, right? Yeah,
I think in my early career, a big challenge was finding a job, my first job, and trying to figure out where I should go, and what university I should work at, and applying for jobs. It was very challenging, not knowing where my husband and I would be moving next, and that uncertainty. That was very, very challenging, because sometimes in science you go where the jobs are, and so we didn't know where we would be next, and so that was a challenge in my early career. Maybe another challenge would be balancing my family life with my science life, because I'm a field researcher, so I go out on research cruises for sometimes months at a time. Some of my other research is in Antarctica, which is that's why I go down. I'm like the Arctic Tern, okay? I go down the same place that those Arctic terns are going, I go every January myself to do research. So I migrate down there and have to leave my family. So that's another challenge. But I got to take my son with me last year. So that was a lot of fun. I got to take him to do research with me. So anyway, there's many challenges, but I will tell you that it has been worth it because I love what I do. And it's always very interesting and exciting. And I have fabulous students like Rob and Bethany and Josh, and and it just
blushing now.
Great.
All vicious rumors and lies. And I guess I don't know if anyone else has a question. I'm going to ask a question. So the project you're working on now is part of NASA. So it's linking satellites' ability to take pictures and detect what's happening in the ocean, and then linking it to what actually is happening in the ocean through measurements and things like that. Do you want to talk a little bit about that? Because that's a super, super cool project.
Yeah, this is this project. It's called Exports, and it's funded by NASA. Is to use satellites up in space that can sense properties in the surface ocean that we can tie to what's happening deeper in the ocean. So for example, you may know that from satellites we can tell lots of things now. Most of our weather information comes from satellites, and also satellites have these sensors that can tell us what the temperature is in the surface ocean. Satellites can also tell us something about what we call ocean color. So phytoplankton, the little plants in the ocean, have different pigments that make them green or maybe golden brown, just like the leaves in the trees. And satellites can actually detect that color and can tell us something about how many plants are in the surface of the ocean. And so what we're doing is studying how what's happening in the surface ocean affects the deep ocean, and specifically how does the plants in the surface ocean, when they die and they sink down deep, how much of that feeds deep ocean food webs, and how important is that what we call export or flux to the deep ocean to feeding the deep sea. Because some of those migrating animals we talked about they live in the deep sea and they're going up every night to feed in surface waters, but there's some animals that don't migrate and they live in the deep dark waters all the time. So what do they feed on? They feed on this stuff. And so it's crazy, but we're using these satellites to try and determine how much tie that into the surface waters and then the deep ocean, and learn about how much of that material is getting into the deep ocean.
It's amazing that a camera or a sensor in space can detect something so small. It's just amazing.
Yeah, it is amazing. It is
we have a weather balloon project. I'm not sure if you're familiar with this, where we're launching these little Raspberry Pis to the stratosphere, and we're taking measurements of temperature and carbon dioxide and things like that. But these get to about a third of the height of where a satellite would be.
Mm-hmm.
So it's pretty cool stuff. And
I remember you telling me you once, I think you called me, you were out searching for one of those balloons that ended up in a field somewhere.
Yeah, it actually almost ended up in your back. Our very first weather balloon launch, it was launched in North Carolina, and because the jet stream was so strong, it was about 10 or 20 miles shy of Chesapeake Bay. So landed up a tree.
Yes.
And that's part of the fun, right? Science.
That's right.
It's part of
Things
the
don't always
adventure.
go as planned, but you almost always learn something from it. Science is very much like that.
Yeah. Yes, 90% is just unwritten. It just happens, right?
Yes.
Yes, very good.
Very true.
So, well, I thank you for your time today, Deb. That was great. And I think Jayla, we have here online. Jayla wants to say something.
Yeah. Hi, Jayla.
Hi.
How you doing?
Good. How are you?
I'm good. That's a cute dog behind you there.
Thank you for teaching us some very interesting stuff. Thank you for your time.
You are very welcome, Jayla. Thank you for listening.
That was great. Yeah. So thanks again, Deb. And I hope everything is okay with the bike.
Yeah. If you want to hear the story, just give me a call anytime. And oh my gosh.
Yeah. Well, there's a good example of life. And stay healthy and safe. And
yes, you
hugs
too,
to the
and
family.
everyone else. Yeah.
Great. Thanks again.
All right.